Alright, so in the next problem I am asked to find the area bounded by the function y is equal to negative x squared plus 1 and y is equal to x squared. Okay, so if you were to graph these functions, which you can do very easily, you would actually observe that y is equal to negative x squared plus 1 is actually here. This is the y-axis, x-axis, and y is equal to x squared is this function here, the blue one. Okay, so they want me to find the area between them. So what I'm going to do is I'm going to find where those two functions intersect in order to get my limits of integration. Okay, this is going to be my left limit, this will be my right limit. To find where these two functions intersect, the x values where these two functions intersect, I am going to set the equation x squared equals to negative x squared plus 1. So let me do that over here. So I'm going to set the equation x squared equals to negative x squared, okay, plus 1, and I want to solve for x. So this is going to imply that 2x squared is equal to 1, and thus that x squared is equal to 1/2, and further that x is equal to plus or minus the square root of 1/2, which I can write as 1 over the square root of 2. So I have successfully found my limits of integration to do this problem. So now let me actually go back to the graph, alright, and show you some more. So I'm going to find the area underneath the largest of the two curves within the limits of integration. Okay, so if you look at it, the biggest curve is y equals to negative x squared plus 1, which is above here, right? The one that is smallest is this one. So what I'm going to do is I'm going to find the area underneath the largest curve, okay, between these two limits, right? So the area underneath the largest curve between these two limits, and then I'm going to subtract the area underneath the smallest curve between the two limits, and this will give me the area in between them. So let me actually do that over here. Okay? So I'm going to set up the integral. I can do that very easily. Okay? So I can do that very easily. So I'm going to set the integral, and my limits of integration are below 1 over the square root of 2 and above 1 over the square root of 2. So that my top function, as I said, was negative x squared plus 1. So I'm going to put negative x squared plus 1 here, and I'm subtracting my lower function. Okay? So my lower function is minus x squared. Okay? And I am integrating this in respect to x. Alright. So now I simplify this over here, and this is going to become, I'm going to simplify this, and this is going to become the integral from negative 1 over the square root of 2 to 1 over the square root of 2 of negative 2x squared, right, plus 1 in respect to x. And I'm going to find the antiderivative of this, right? So I'm going to find the antiderivative of here. So this is going to become minus 2x to the 2 plus 1, which is 3, divided by 3, plus, okay, x, and then I have to, once I find this antiderivative, which I found over here, I now have to evaluate it above at 1 over the square root of 2 and below at negative 1 over the square root of 2. So what you do is, okay, you write two parentheses, and I'm not going to do the whole problem for you, okay? And you put a minus sign in between them. And this, inside here, you put in this expression, the whole antiderivative, evaluated at 1 over the square root of 2. Okay? So you put the whole derivative evaluated, when you substitute for x, 1 over the square root of 2. Okay? Whenever you see x. So that goes here. Then, what you do, let me use another color, is over here, you have, notice the minus sign, you're going to evaluate this expression at negative 1 over the square root of 2. So wherever you see x, you substitute, wherever you see x, in the antiderivative, you're going to substitute, okay, negative 1 over the square root of 2. Okay, so that's going to go in there. And then when you finish with the arithmetic involved in that, you will have the area bound between those two curves. Thank you for listening.